Welcome to qnawire.
Okay, we have two substrates. Cyclohexane with a methyl and a chloro group, as well as a substituted benzene. And in bond line form, this would look as follows. CH2Cl would just be a carbon with two hydrogens and a chlorine attached, which makes it a little more clear when we start looking at this reaction what is possible. Okay, so in the first case, we are reacting this with sodium methoxide in methanol. And in the second case, we are reacting this with sodium hydroxide in water. And the question is, what type of reaction will take place in each case? Now, you've correctly labeled this as being E2. And we know this is E2 because methoxide is a strong base and a strong nucleophile. However, our polar protic solvent favors elimination. So between SN2 and E2, E2 is favored as you have selected. Now, let's look at this case in which we have a primary chlorine, right? Primary carbon bearing the chlorine, and sodium hydroxide in water. Now, you may think, again, well, this is a strong base, strong nucleophile, which is true. So you're talking about SN2 versus E2. And then you may look at the solvent and say that this is polar protic and therefore favors elimination. And think that this too would be E2, but recall that a necessary component for an E2 reaction is a neighboring carbon with a hydrogen that can be oriented anti to the chlorine. Well, this is the carbon which bears our leaving group chlorine. And so a neighboring carbon, or the only neighboring carbon, is this carbon here. And because it has a bond to carbon, and a double bond to carbon, there are no hydrogens available to take part in the E2 reaction. Therefore, E2 is not possible because of the substrate, which means the only option is for SN2.